Hello and welcome to Bloke on the Range. And a question I get asked a surprising amount is why Enfield bullpupped an AR-18, basically, to make the L85 series of rifles, rather than simply scaling an EM-2, which was the prototype rifle, bullpup rifle, adopted in the late 40s, early 50s, before being rapidly unadopted for largely political reasons. On the channel, we've had the privilege of being able to show a factory semi-auto L85 A1 a few times. It's not mine, so I unfortunately don't have it here to illustrate any points. Thanks again to its owner who turns up at the range, lets me use it, takes it away again. So what this basically comes down to is that, well, simply scaling the EM2 is doing an awful lot of work there, and you'll see why as we go through this. The first thing we need to look at is what is and isn't, or rather was and wasn't, the EM2. So what it was actually kind of large. Well, let's do some stats. 889 millimeters against 1003 for an M16A1, so it's only about 4.5 inches shorter. It's kind of heavy. It's about 0.6 kilos or 1.3 pounds heavier than an M16A1. It was chambered for a much larger cartridge than 223 Remington or 5.56 NATO. The second model of the cartridge actually had a 308 Winchester casehead diameter and was only 6mm shorter than 308 Winchester. And in fact, the last ones were even chambered in 7.62 NATO to see as whether they could compete with other designs. It's actually a surprisingly large cartridge. When we think of intermediates these days, we think of 8x33, 7.62x39, 223 Remington, which are sort of 300-ish meter, 400-ish meter cartridges. This was a much bigger cartridge, which was designed around the British Army's sort of 600-yard infantry doctrine. So it's quite a bit chunkier than any of those. The design, although to a certain degree it looks like it's stamped, it's not. It's actually designed for 1940s manufacturing tech. So big lines of horizontal mills and shapers, single point cutters, that sort of thing. And this is a major point that we'll have to come back to in a minute. What it wasn't was a mature design. There were only about 60 made in total in, well, the two different types of 280/7mm and 7.62 NATO. So with those sorts of production models, we're talking about little more than toolroom prototypes. I mean, the rifle had been adopted on paper as the rifle number 9 Mark 1, but there'd never been any large-scale troop trials with it. There hadn't been time for a lot of the problems to appear, both in production and in use. And I think it suffers a lot from what I like to call magic rare unicorn prototype syndrome, where people think, oh, it would have all been fantastic if only this rare rifle had been adopted, as if the rare rifle wouldn't have suffered the same issues that practically everything else that's ever adopted ever suffers to some greater or lesser degree. A little anecdote for what it's worth, and really it's for what it's worth. When I was at school, I met a guy who was driving a coach for some visiting team, and he claimed to have been a national serviceman in the right era, and said that they were on a range day, and one of the DS turned up with his shiny new rifle and gave them all a speech about how it's the new great thing, it's the next big thing, we're having this superb rifle, look at it. And he gets down into the foxhole firing position there, whacks on a magazine, starts loosing rounds, and then it jams absolutely solid. And to cut the long anecdote short, he ended up kicking it open with his boot while swearing and effing and blinding at what a piece of crap it was, etc. With only 60-ish prototypes out there, I can believe stories like that. I mean, it could just be an ex-national serviceman spinning a yarn, but it's entirely plausible, to be honest. But take it for what it's worth. So the two main points we've got to discuss here are scaling down and changing to stamping. And for a lot of new post-war development, stamping was the new hotness, it was the new thing. You could, in principle, make things lighter, and for large production runs, cheaper. The setup cost for tooling for stamping is enormous, which is why you don't do it for small production runs. And as a little aside, there's always discussion on the various French forums as to getting tooling made up to make Berthier clips or clips for the French semi-auto First World War rifles, but when you've only got potentially a dozen people who would want to buy these things, the massive tool cost just to get set up, just to prototype them, is just vast. You really can't imagine. Nowadays, with CNC machining, we've gone back the other way. We've gone back to machining from solid. Labour costs are higher these days. Material costs are comparatively less. You don't mind so much putting in a block of metal into a CNC machine, pressing a button and walking away. But back in the day, the FAL being an exception because that's a machine design, but when you think of G3s and all sorts of other things, and one we'll come back to, the AK. So the simple matter of scaling down, and we've got another example of this where Ruger scaled down M14s to make the Mini 14, and that involves basically scaling down a 7.62 NATO rifle into something with an action that's not actually that much bigger than an M1 carbine action. Now the pressure in 223, I think from now on I'm just going to call it 223 and 308, just rolls off the tongue more easily. So the pressure that you've got to withstand with a 223 is actually a little bit higher than with a 308. But everything you've got to make it smaller. So it's not just a question of taking the dimensions from an M14 and making everything smaller so that it fits the cartridge and it works. You haven't got enough material. You've actually got to do a significant amount of rework and redesign just to get it to be structurally sound for the pressure it needs to take. And that was without any issues related to completely changing the manufacturing technology. Now they did cast the receivers instead of machine them from a block of solid, but even so, it's still traditional machining that they're doing that with. So you've got to go back to basics. You've got to do an entirely new set of stress calculations. You've got to change proportions. I mean, the aspect ratio, the length to case head diameter of a 223 is quite different from a 308. It's much longer in comparison to its diameter. So you've got a whole redesign, and you end up with something that is obviously based on the M14, but when you look in the details, it's moved away from it a fair amount in lots of ratios, dimensions, things like that. You've also got to redo the tolerancing entirely, and we mentioned this in a video we did ages ago on the Lebel rifle and adopting that quickly, and why that was based on a design they already had in hand, as in the last model of the naval Cropper check, because they had toleranced drawings for all of that. And the issue with tolerancing is that you can't cut something to be exactly, say, 5mm. It's always 5mm plus minus. And the smaller that plus minus, the more it costs, the more difficult it is to do, the more reject rates you have. And what you've also got to be able to do is ensure that if you've got part A and part B that have to fit together, you need to make sure that a maximum tolerance part A will fit with a minimum tolerance part B, or vice versa. Otherwise you end up having to hand fit and hand select. And interesting aside, in the 1903 Springfield manual, for getting the headspace right, they literally just try bolts until one went between a go and a no-go gauge. And if they couldn't get one, then they sent the rifle back to the factory. Which is a way of dealing with tolerancing. I mean, we're talking, headspace is fairly long tolerance, but you've got lots of things that have to work together with them to get something that worked. Anyway, stupid aside, Armalite had exactly the same issue with the initial scaling down of the AR-10 to what was really the first AR-15 prototype, which they did actually in 222 Remington, not 223 at the time. They literally just scaled it down, and it wasn't structurally sound. Apparently it failed. I've been many thanks to Nathaniel Fitch, who was formerly of the Firearms blog and has been helping me with some of the interesting details and asides on this video. Now, another point that Nate actually brought up was that on the one hand you've got the mechanical resistance to pressure of the breech mechanism, but it also has to be sufficiently structurally sound to be soldier proof as well. And as an example, from the first 222 Proto up to the M16A2, the M16 grew 34% in weight, and a lot of that is just structural integrity to be soldier proof and survive use in the field and rough handling. And a lot of that was actually pre-1968, so well before the A2 thicker barrel and other reinforcements went on. So I think that's the general principle of the issues with scaling down dealt with. So the next one is changing manufacturing techniques. Now, it's really not trivial to go from a machined design to a stamped design. The other way around is a bit easier. As an example, it would be very, very difficult to make a stamped AR-15, but you could probably make a machined AR-18 without too much difficulty. It might be heavier, but in terms of just physically engineering it, it's quite a lot easier. And it's best to design things for stamping from the ground up to work with the advantages and the limitations of the stamping technology. Now, I mentioned the AK earlier, and I probably have people tapping away in the comments saying, "Oh, but the original AK was machined." Actually, the prototypes were stamped. Here's my pure Chinesian one, Type 56S for those that care. The AK was originally conceived as a stamped design, and basically the lower receiver, or the receiver as it is here, is basically a girder designed for stamping. Soviet industry couldn't cope with doing that in mass production, so they re-engineered it for machining from solid, which is easy to do because you can make a girder out of solid and machine it. And then with the AKM in the 60s, it went back to mama and went back to stamping with actually much more advanced and clever stampings, which is why the AKM is actually quite light, and it's actually made out of 1mm steel. It's really quite light steel. These Chinese ones, on the other hand, are actually 1.5mm steel because they reverse engineered them from RPKs. And they kept the same thicker 1.5mm steel all the way through. About the only exception I can think of to this is the FG42, where the first ones were forged receivers and then the second models were stamped. But on the other hand, we're also talking again about low production numbers, okay, way more than the EM-2, but FG42s have a bit of an aura about them. Part of it is rare, almost prototype syndrome. Part of it is the whole grout space magic thing.
I must be tripping.
A major issue with stamping technology is that the material thickness is constant. It's just a sheet of steel, and you stamp holes in it, and you stamp shapes in it, and you fold it up, and you weld it up, and you get to your final receiver. If you want anything thicker or stiffer, you've either got to weld more material onto it, whether it's a machine block like the trunnion, for instance, where the barrel attaches, or other bits of stamped steel, or you've got to stamp sort of elongated dished shapes into it to give it a bit more overall thickness. And it's really non-trivial to do this when converting a machined design. So it's basically, you often just physically can't make the same shapes that you're trying to convert. For the EM-2, you would have to redesign basically everything. I mean, in the original machined design, all the guide rails and so on are integrally machined into the receiver. You don't have to worry about adding them on and tolerancing it, and every extra piece you add on, you've got to tolerance it all, it's got to work together, you've got to make jigs. It would be a real ball ache to do that with the EM-2. Plus you've got to scale it down, plus you've got to do the stress calcs, plus you've got to do the tolerancing, and then the locking system, it's flappy paddle locking, like a G43. And so compared to a rotating bolt, which is really, you've got a bolt extension and a bolt head, and it's just two parts, and they just rotate and lock into each other. You've got so many points of contact that have to be in the right place. Each pair of those has to be toleranced correctly. With a stamped receiver, your trunnion has to be a little bit longer than it would be for a rotating bolt, because you've got to get the bolt head in, and the flappy paddles have to be able to come out and lock, which complicates your feed pathway and your ejection pathway. And it's just, basically, it's kind of, you didn't want to start from here kind of thing. Little aside, another thing that Nate brought up was that, as a sort of kind of extreme example of this, is that the German Sturmgewehr 44 actually has a machined sort of sub-receiver inside the stamped outer receiver that's sort of clamshelled in and welded in to get around some of these issues. But it's actually a fairly sizable piece in there that they've machined, because that's a rear tipping bolt. So you've got to have the trunnion and then somewhere for the bolt to lock into, and then the magazine has to go through it. And actually, quite complicated. So, in view of all that blather, it should be clear that it's much easier to ideally license, or in the case of Enfield, steal, a design that's already the right size because it's already chambered in the same cartridge and it's already in the right manufacturing technique than to deal with all of that nonsense. In fact, some of the early prototypes of what then became the Enfield weapon system, the L85, were cut and shut up from AR-18s. And there was actually another one done from a Stoner 63. So they weren't just looking at that, but it was all mature stuff. And by the time period we're talking about here, which is sort of mid-70s, when they're starting to work on that, the AR-18 is already a moderately mature design. It certainly works, it's in production, it's not got any major customers. And ultimately, of course, it ends up as the basis for so many other modern day weapon systems. So the basis of the design is absolutely sound. So when you can do that, why would you go back to a sort of late 40s prototype where literally everything about it is wrong? You haven't got the know-how. I don't know if they destroyed the jigs and tooling, but anyway, the jigs wouldn't have helped because you'd have to scale everything down anyway. It was 25 years old by that time, so anyone with any know-how about it would have been young at the time of its development and old at the time when they're making prototypes for what became the L85. And in any case, any know-how in those people's heads would be invalidated by the fact that you've got to scale it down and change everything anyway. So you're really making a rod for your own back rather than just saying, okay, we'll take this and we'll shuffle it around a bit and there you go. Easy. Simples, right? Well, as we know, they made a complete balls up of it. And not going into the ergonomic issues and bad plastic choice and magazine releases that bashed on your kicks that were slung across your front and dropped your magazine. Just the sheer reverse engineering of the action, they just got it wrong. I mean, Enfield were too proud and too stingy financially to get Sterling on board to help. I mean, the obvious thing would have been get Sterling on board, basically sub-license the design from Sterling. What typically comes with a license is not just the rights to produce, it's also the technical package that comes with it. So dimension and tolerance drawings and know-how. As the ideal protection for something is not only patenting it, and actually Enfield got around the Armalite patent by bullpupping, because it's quite a specific patent. That's a topic for another day. So there weren't any patent issues that they were worried about. But when you license a product to manufacture it like that, typically you're getting all the secret knowledge that comes with the hows and whys and wherefores. Why is that angle 33.6 degrees and not 45? And then Enfield come at it and they look at and like, that angle's silly. Why is that angle 33.6? It's much easier to cut it at 45. Should we look at 45? 30. Nah, let's just cut it at 30. And actually there's a good reason why it's, say, 33.6. That's been worked out by the original people, and by not incorporating that in, you're causing issues. And the big one that they cause will increase the dwell time. The bolt's quite a lot longer on an L85. The bolt carrier goes back a lot further before it unlocks, which will serve to reduce the residual chamber pressure when it unlocks. But on the other hand, there's a reason why it was short in the first place. And that seems to be a cause of a lot of the stoppages when everything's a bit marginal, as they were in the rifle. I mean, Sterling were clearly hoping that they would at least get some consulting or some subcontracting work, because in 1978 the director of Small Arms, Stan Carroll, got a very detailed guided tour of Sterling's factory, and it seems that actually all he was doing was looking at what automated machines Sterling had been using to produce parts, just as a form of pretty much open industrial espionage. And Sterling were being burned. Sterling had been burned previously with the Sterling submachine gun. Ended up suing the British government and winning, because Fazakerly the War Department just turned around and said, well, we're the British government, we're going to make them tough. And that had to be taken to court to get a good settlement out of that. So back at the plot, so if you're going to reverse engineer something, it's easy to buy a couple of examples and measure everything and then make up drawings. But then we come back to tolerancing. You don't know where in the tolerancing ranges those are, and you don't know what the tolerances are. So this all leads into the problem of a lot of the reason why they screwed up the SA80 in the end. Another piece in the story is the internal culture at Enfield. The way into the design bureau was apparently, and I'm informed by people who knew people at the time, that you served your time as a draftsman. So maybe you went and studied fine art or something and ended up doing technical drawing because that's where the jobs were. You served your time in the drawing office as a draftsman before being promoted to the design bureau, and so you've basically got non-engineers, people with no engineering background, making critical engineering decisions about things that they don't necessarily know enough about to be making decisions on, and mistakes got made as a result. So in view of all that, and particularly in view of the difficulty they had simply ripping off and bullpupping an AR-18, can you imagine the fun they'd have had trying to do a scaled down EM-2 practically from scratch? I mean, basically it would look a bit like an EM-2, it would be vaguely based on it, but it would be an entirely new rifle from scratch. And if you can't successfully reverse engineer a well worked out and pretty mature rifle, you're going to struggle. So one final point, which is another bloke on the Ranger side, and I'm going to just illustrate it with another AR-18 derivative, my Australian International Arms semi-auto carbine. Why do bullpups end up so heavy? Because, I mean, an L85 is surprisingly heavy, even with iron sights. And in an earlier video, I shot it next to my M16A1 on the range, and the weight difference is quite remarkable, even without the SUSAT. And the answer is simply that with a conventional layout, from here to here is the only bit the receiver needs to be. The butt can be of polymer or metal or whatever, but the butt is literally just structural. The fore end is just something to hold. As soon as you, let me just pop that pin, they're not as captive as they should be. So, as soon as you bullpup it, let's just try and hold this up like that. You end up with something a bit like that. The upper receiver needs to go back to the butt plate. The magazine housing goes behind, obviously, as he drops his breech block. Be easier like that. So you end up with a situation where that goes behind, but you need receiver metal from there to there in the lower, from there to there in the upper because it has to interface, and then that's assuming you don't want an outrigger on the front to hang the stock off of. So you end up with actually a massive amount more sheet steel in the receiver to do the same thing. You think it's smaller, it must be lighter, but you've actually got to use a lot more steel to get there. And that's kind of the piece of the puzzle for what it's worth. So, thank you very much for watching, if you survived this far. Thanks again to Nathaniel F. For all the assistance he gave me in making this video. Thank you very much to our patrons, and if you haven't considered becoming a patron yet, please consider doing so. It really helps us to keep acquiring nice things to show and to keep the channel ticking over at a one video a week rate. And yeah, thank you very much to all our existing patrons, and newcomers are always welcome. So thanks a lot. See you again. Bye.